Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 8th students of various branches of Krishnaveni Talent School, Mastermind Schools and Oakley International School. As you all well aware, and you can see on the screen, my subject is physics. We are in class 8. Our ongoing chapter, the last chapter, heat. Today we are entering into the session number 2. Already we started this chapter on Tuesday, that is 2 days back, about the heat. And then we enter in the second session today. So we'll continue where we stop in the last class. But before that, let us recall what we learned in the session number 1. Simple, we learned about only 2 topics, 2 words. The last session, that is, what is temperature and what is heat. Heat and temperature. So heat is a form of energy, right? Heat is a form of energy which makes the body hot or cold. When heat increases, it becomes hot. When heat decreases, it becomes cold. Such a form of energy is called heat. Heat always travels from hot body to cold body. Hot body to cold body until both will become same temperature, which is called thermal equilibrium. Heat energy is also called thermal energy. Very important point. And as you cannot measure the heat, the measurement of heat, whether the heat is hotness or coldness of the body, is called temperature. The degree of hotness or coldness of the body is called temperature. Heat is the cause, temperature is the effect. Without heat, there is no temperature. Whether temperature is increasing or decreasing, that is represents the heat only. These two are the mutually convertible words or terms. Okay. So about these two, we discussed in the last session. So further we'll see more about the temperature and heat. So this is what we learned in the last class. So what is heat? Heat is a form of energy which is makes the body very hot and travels always from high temperature body, that is hot body, to cold body. It is measured in joule or calorie, where 1 calorie is equal to 4.18 joule. Then temperature we have seen. So whenever heat increases, when work done increases, heat also increases. From that we got one new word J, we can see on the screen. Then temperature. It is effect of heat. Because of heat, temperature rises, right? This is nothing but either hotness or coldness of the body. The degree of hotness and coldness of the body is called temperature. Clear? So if you want, you can note down the synopsis points, very important. First one is, what is heat? Heat is form of energy. It is form of energy which transfers from hot body to cold body. Hot body to cold body. Right? Hot body to cold body. Is also called, the heat energy is also called thermal energy. Note this is the first point. Thermal is nothing but heat. Thermal energy. So Heat is a form of energy which transfers from hot body to cold body, also called as thermal energy. And second one is units. When you see the, I think already I told units. Heat is measured in, first one is joule or calorie. CALORIE, calorie, where 1 calorie is equal to 4.18 joule or 4.2, you can say sometimes. These are the 2 points about the heat. And one more is a third point also. Just note down the 2 points. Third one is, so the work done is directly proportional to heat produced. Will you agree or not? As you are doing more work, more heat is produced. So from this you can get to remove the proportionality symbol. The symbol, they use the word constant J. W is equal to JQ, right? Or J is equal to W by Q, work by heat. Q is nothing but heat. Heat is represented by either Q or H. So the work done is directly proportional to heat produced. Greater the work done, greater the heat produced. From that, we got one very wonderful equation where J is called Joule's constant. J is the Joule, name of the scientist. Unit, Joule's constant. Right. So these are the points, 3 points about the heat. So definition of heat, unit of heat, and effect of heat. Effect of heat. Right? So take some time to know. Then, so what happens if heat raises, or how can you measure the heat? So heat only you can feel. We cannot, if you want to measure, that is comes under temperature. Whether the body is hot or cold, that is found by the temperature, which is the degree. How much we measure in degrees? Degree of hotness or coldness of a body. Degree of hotness or coldness of the body is called temperature. You can see at the bottom, last of the page, you can see what is the temperature is given. Right? The temperature is the effect of heat energy, which determines the thermal state of the given substance. In other words, it determines the degree of hotness or coldness of a substance. Right? That depends on the surrounding temperature, whether the body is hot or cold. Sometimes when you go morning time, you can find very hot outside. Evening time, very cold. Both are comes under temperatures only. Both are comes under temperatures, whether it's a hot body or a cold body. Hotness or coldness. Right? Such an hotness or coldness of the body is called temperature. So that's what we have seen in the last class. So you can note down the fourth point also. Fourth point, you can note down for the temperature. Side heading is temperature. So answer is the degree of hotness or coldness of a body or a substance is called temperature. Point number 5. Heat is cause. Heat is cause and temperature is effect. Heat is cause, temperature is effect. And next also we can add one more point. Measure units. Unit of heat, unit of temperature is either Kelvin. Temperature is measured in either Kelvin or Celsius. So many are there, later you can come to know. Unit. So 3 points on heat, 3 points on okay. So temperature is nothing but the degree of hotness or coldness of a body. And temperature is a, heat is a cause and temperature is the effect. The unit of temperature is either Kelvin or Celsius. So very important question for your regular syllabus also, the difference between heat and temperature. They ask in the table form, which I'll show next. Right? You can see the next page where you can find the table also. If you are not written, you can copy this also. Temperature is a measure of relative degree of hotness or coldness. Heat is a form of energy. Temperature rises when the body heated and fall when body cool down. Still clarity is there. Heat flows from body at high temperature to a body at relatively colder temperature. The SI unit of temperature is Kelvin. Right. The SI unit of temperature is Kelvin. The SI unit of heat is Joule. It is measured using a thermometer temperature. And heat is measured during calorimeter. We are going to learn next. Since temperature is a property, it does not have any working ability. Being form of energy, heat has ability to do work. So heat is energy, so you can do so many works. We are cooking the food, we are enjoying the hotness in the summer, winter. So many things you can do with heat. But temperature we cannot do because it's only a effect only. Right? So now this table also got 5 points. Very important table for even for your regular syllabus. Completed? Right. So when you move to the next year, the scales of thermometers. So temperature already given here, units and everything we are written. The next, when you come to the second part of the chapter, the second synopsis. So scales of temperatures. So how to measure the temperature in the various scales? So it is somewhat. So there are two main scales are there. Of course, there are so many are there. First one is Celsius scale. Celsius. Second one is Fahrenheit. Fahrenheit. And third one is Kelvin. And fourth one is, we can have the, one more is there, Reaumur. Right. So a Kelvin also called as absolute scale. So there are different scales where we can measure the temperature. So based on their minimum value and maximum value, that is called lower fixed point and upper fixed point. You can add the scales, right? So before going to explain about the scales, let me show you the video on these scales of thermometers. Later we can go for the explanation, right? So just watch the video to know about the what are the various scales of thermometer, right?
Temperature. There are 3 different types of temperature scales, but I just want to start with what is temperature. Temperature is defined as this. It's the average kinetic energy of the particles of a sample. Now you may remember from introductory physics that the kinetic energy is calculated by taking half the mass and multiplying it by the square of the velocity. What? The velocity is like the speed. It's how much distance is covered per second. And then the mass, of course, is like weight. It's the amount of matter. So it's how much moving how quickly. That's what temperature is measuring. Now, it's very often measured in chemistry, not using Fahrenheit. We're used to Fahrenheit just out about in the world here in the United States. But in chemistry, temperature is most often measured in Kelvin or Celsius. Kelvin is kind of the best for chemistry, and there's a reason for that, and I'll show you in this video. There are 3 common scales of measuring temperature: Fahrenheit, Celsius, and Kelvin. At this temperature here, water boils. Do you know what temperature in Fahrenheit water boils at?
So
It's 212 degrees Fahrenheit. It's kind of a strange number. In Celsius, this is where the Celsius scale comes from. It was determined that we were going to set 100 degrees Celsius at the temperature at which water boils. For kelvins, which is probably of these 3 the most foreign to you, Kelvin is 373. Now that's kind of a strange number as well. But let's keep going. What if I lowered the temperature to the temperature at which water freezes? And we probably know this, but water freezes at 32 degrees Fahrenheit. In Celsius, water freezes at 0 degrees Celsius. So I just want to show you this. The Celsius scale from 0 to 100 comes from what water does when it changes phases from solid to liquid to gas. And so that's kind of the whole genesis of the Celsius scale. It's that.
So here 3 scales are there. Of course, 4th one also there. The minimum temperature we can measure with this scale is 32 Fahrenheit. 32 Fahrenheit. Up highest is 212 Fahrenheit. Means if you calculate, there are totally 180 divisions. The difference 212 minus 32. That is called range of this thermometer. Whereas Celsius thermometer starts with the 0 and highs with the 100. So total divisions are 100. Range of the Celsius thermometer is 100. So Kelvin starts with 273, ends with 373, again 100 only. So this is called lower fixed point. This is called upper fixed point. So the difference between upper and lower is called range of the thermometer scale. So these are the scales of thermometers. Means we can measure, we can convert. For example, if you see newspaper, table you can find temperatures of the city. They'll give in both Celsius and Fahrenheit also. So how the conversions, that we can do the relation. So these are the 3 temperature scales based on their lower fixed point and higher fixed point, and their ranges, they are classified. Okay.
At 0 being water freezing, 100 being water boiling, and then off of that we can just kind of scale it up to measure temperature for everything else. Room temperature in Celsius is about 23, 25 degrees Celsius, somewhere in there. In Kelvin, the temperature at which water freezes is 273 Kelvin. Now I want to pause and point out one major thing here. If you look at the difference between the temperatures water boiling and water freezing for Celsius, what you'll notice is that's 100 degrees. It's the same gap in the 2 measurements for water boiling and water freezing in the Kelvin scale. So what this means is that a change in 1 degree Celsius, a change in 1 degree, that delta means change, is equivalent to a change in 1 Kelvin. So they're not the same scale, because otherwise these numbers would match, but their increments are identical. They have equivalent increments, and that makes Celsius and Kelvin really easy to kind of play with each other. Now, there is one more thing I want to show you, and that's this. Well, what if I have absolutely no molecular motion? The velocity of a particle on average is 0. That means molecules have completely frozen. That's something that's called absolute 0. And in Fahrenheit, that's this relatively arbitrary negative 460 degrees Fahrenheit number. In Celsius, it's negative 273, and maybe you can figure out what it would be in Kelvin. In Kelvin, it would be 0. And so this explains why Kelvin is a separate scale from Celsius. Celsius is based off of what water does when it changes phases. Kelvin is based off of the fact that at 0 Kelvin, we have absolutely no particle motion. And now that's theoretical. We haven't gotten there, thankfully, because we'd all probably be dead. But that's what the Kelvin scale is based off of. What that also means is that it's impossible to have a negative Kelvin temperature. All Kelvin temperature measurements are positive. One other thing to mention about this is because Fahrenheit just really doesn't have a very solid reason for having this scale. In chemistry, we tend to ignore Fahrenheit completely. Now, of course, it may be interesting to you to convert Fahrenheit degrees to Celsius or Celsius to Fahrenheit, just so you have an idea of what a certain Celsius measurement is based on what you're used to. But in chemistry, we will not use Fahrenheit. And for that reason, in this video, we are not at all going to talk about how to get between Fahrenheit and Celsius, or Kelvin for that matter. I just want to show you how to convert between Celsius and Kelvin, because that's what we'll do so often. But first, this concept, absolute 0. It's the theoretical temperature at which all particle motion stops.
Where all the particles motion stops, that position is called absolute 0.
Stops completely, and it happens at 0 Kelvin, or negative 273 degrees Celsius. Now, how do I get between Celsius and Kelvin? Well, if you look at those scales enough, you'll eventually pull this out. If you take a Celsius degree measurement and you add 273 to it, it gives you what the value would be in kelvins. Or if I kind of flip this around, I get K equals C plus 273. Now, what if I was given, or I have a Kelvin value and I want to figure out Celsius? Well, it's very simple. You just subtract. So flip it around. Celsius is Kelvin minus 273. So let's try a couple of these. Pause the video now. Try these on your own. And then
so 585K, we can convert into C. So C to convert K to, by using that formula. K is equal to C plus 273, or C is equal to K minus 273. Plus and minus, that's all. Okay.
I'll show you the answers in just a second. 585 kelvins is equal to 312 degrees Celsius. I just simply subtract 273.
See, you want to convert into C, what is that will get anyway. I'll explain you the relation. So C is equal to K minus 273 formula. So K how much here? 585. 585 minus 273. We'll get the 312. So like that you can do. If you want K, you want to convert into K, K is equal to C plus 273. C is 25. 25 plus 273 is, we'll get the 298. So that is how to convert the one scale into another scale. That will come to know later. Right? Like that you can convert any scale into any scale.
If I'm given a Kelvin value, subtract 273, and that gives you the Celsius version. Same thing here, 52 kelvins, subtract away 273, and that should give you negative 221. Now here I'm going in the opposite direction, so I want to do just the opposite. Instead of subtracting, I want to add 273. This is room temperature, by the way. 25 degrees Celsius, 298 Kelvin. That's kind of what it's like in my room right now. And then 145 degrees Celsius, again, add 273. That gives you 418 kelvins. Now, the one thing I did not mention is that kelvins do not have a...
required. So clearly explain about what are the scales of the thermometers. So there are 3 scales are there for thermometer, which we can say it as, one is Celsius or centigrade scale. The first one is Celsius or centigrade scale. Second one is Fahrenheit scale. Third one is Kelvin scale. Okay. So the first one is, for example, Celsius scale starts from 0 to 100. Fahrenheit scale starts from 32 to 212. Kelvin scale starts from 273 to 373. So as per our requirement, we can use them, and you can convert them from one form to another form. Okay. So the 0 is called lower fixed point. 100 is called higher fixed point in case of Celsius scale. In case of Fahrenheit scale, 32 is the lower fixed point. 212 Fahrenheit is the higher fixed point. The difference is called range. Range of Celsius is 100. Range of Fahrenheit is 180. That only given there, 180 parts. Range of Kelvin is 100. So like that, there is a various types of scales which can use for the measuring the temperature, and even you can use for the conversion from one scale to another scale. See here, clearly picture given: upper fixed point, which is called boiling point; lower fixed point, which is a melting point. Right? So which already clearly shown in the video, same thing is here in the picture. So when you come to the part of the relation, what is the relation between these? Rumor also given here. What a fourth one? R. So there are 4 scales relation is given. So one is C minus 0 by 100, F minus 32 by 180. R is nothing but rumor. Rumor scale, if you take, it is 0 to 80. That is, range is 80 only. Starts with 0, ends with 80. The purpose of utilization conversion is different. So this is the formula here. The standard formula for how to get the formula means simple. Scale minus lower fixed point by upper fixed point minus lower fixed point. What is scale? Suppose we take C as a scale. C minus lower fixed point of C is 0. Upper fixed point is 100. Minus lower fixed point is again 0. So we get C by 100 for Celsius scale. Right? When come for Fahrenheit scale, F minus, what is lower fixed point? 32. By 212 minus 32. We'll get F by 180. That is came here. F minus 32 by 180. So R by 80. K by 2, K was 23 by 100. So this is the relationship among the all the 4 scales by which we can convert one scale into other. Suppose if they given 30, C is equal to 35 degrees. What is this value K? K is equal to how much? So I take only C and K, remaining no need. C, K relation is there. C by 100 is equal to K minus 273 by 100. 100 cancel. So C is equal to, as already we have seen in the video, 273. What is C value? 35. So 35 is equal to K minus 273, or K is equal to minus, we'll go this is plus 273 plus 35. That is 308 Kelvin. That is 35 degrees Celsius is equal to 308 degrees Fahrenheit. Like that, you can convert any degrees into any Fahrenheit or any Kelvin also. Sorry, Fahrenheit that is, not Kelvin. You can convert like that only by using that relation, right? So in deeper details about the relation and the problems, we'll discuss in the next class. Lot to learn in the heat. So third synopsis about the how their expansion takes place. When your body is heated, how it expands, whether solid, liquid or gas. That is expansion, thermal expansion. We'll discuss expansion of solids, expansion of liquids, expansion of gases, right? Different way they expand, and very good thing to learn here. So next we'll get the few important definitions regarding this one, heat, which we are going to learn in the next class. Specific heat, latent heat, and few solid examples. Okay. So there is no work for you, only work on the heat and temperature and scales of temperature. Already you maintain the synopsis, write it clearly and take the correction from your parents and teachers, right? So that's all for today. Thank you all of you. Have a wonderful day. Thank you.